student, welcome to lecture 1. Today we are going to study solubility. We will discuss solubility, solubility expression and mechanism of solute-solvent interaction. So, first we will begin with the definition of solubility. What we understand by solubility? Solubility can be defined qualitatively and it can be defined quantitatively. Qualitatively, it can be defined as a spontaneous interaction of two or more substances to form homogeneous molecular dispersion. When we say that homogeneous molecular dispersion, that means the particle size will be in an angstrom and the particle cannot be seen by even by electron microscope and the particle cannot be settled down by using centrifugation forces and the particle will not be able to scatter lights. So, molecular dispersion is also known as true solution. Now, quantitatively we can define solubility as concentration of solute in saturated solution at constant temperature. Next, before starting with the solubility and knowing about some of the terms which are used in solubility, we should understand why we have to study solubility and why it is so important in pharmaceutics to study solubility. Actually, solubility in pharmaceutics, whatever we do, so we have to prepare solutions. And if we consider formulation, then if we prepare monophasic formulations like parenterals, syrups, elixirs, then also it is required that the drug should be soluble in the liquid solvent given. So, we have to study solubility to get an idea about what type of solvents we have to select, as well as we know that the drug after getting absorbed, means after taking inside the body, as we intake the drug, then the most of the drugs, specifically when we take orally, then the drug has to be transferred through passive diffusion, and when the drug is passing through a passive diffusion, then what happens, the main criteria is that the drug should be in soluble form, then only it will get absorbed through the cell membrane. And most of the drugs which have solubility problem, they show bioavailability issues because we know that bioavailability depends on solubility and permeability. So, now we will study some of the terms which are used in solubility. First, solution. What is a solution? It is a homogeneous mixture of two or more components, and it is mainly consists of your solvent and solute. Solvent which is present in large quantity and solute it is present in lesser quantity. Then we will study about the degree of saturation. Now, degree of saturation, according to this, we can categorize the solution into three types. One is your unsaturated solution, then saturated solution and supersaturated solution. So, we will begin with unsaturated solution. Suppose we are taking A as the solute, okay, and we found that the solubility of A is given as 10 mg per ml. Okay. Now, if I take a container containing 100 ml of solvent B, suppose B is taken as the solvent B, then if I add 10 mg of A and then I just stir it and it forms a homogeneous molecular dispersion. Okay. So, now we can say that in 100 ml of solvent B, we have 10 mg of drug. That means, the concentration here in 1 ml it will be it will be 0.1 mg per ml. Okay? And here this 0.1 mg is much less than that of 10 mg per ml. So, we can say that an unsaturated solution, which can also be called as a subsaturated solution, is the one which contains dissolved solute in concentration much below that necessary for complete saturation at a defined temperature. Yes, whenever we perform the experiments related to solubility, whenever we have to find out this degree of saturations and solubility, we have to mention the temperature. So, it would be more perfect if I mention 10 mg per ml at 25 degree Celsius temperature, because solubility is affected by change in temperature. It may either increase with the change in temperature, it may decrease with the change in temperature, or it may remain unaffected. We will study these factors when we study the factors affecting solubility in our next lectures. Then comes the saturated solution. What happens in saturated solution? Now, as we will take the previous one example, here we are taking solute A and I keep on adding solute A in 100 ml of B, solvent B. Okay. So, first I added, it mixed, and we know that the as it was found that it has a solubility of 10 mg per ml. It was previously detected at 25 degree Celsius. Now, if I go on adding 10 mg, then again 10 mg, 10 mg and like on, I just go on adding the solute to the solvent. What happens? A stage will come when some of the solute, that is A, will not dissolve, it will remain in the undissolved condition. So, now an equilibrium exists between the undissolved form and the dissolved form at a particular temperature, at a particular temperature. Okay. Okay. So, now we can say that the supernatant fluid is a saturated solution, because now equilibrium is established between the dissolved and the undissolved solute at a definite temperature. Then comes supersaturated solution. Now, in supersaturated solution, what happens? It contains more of the dissolved solute than it would normally contain in a saturated state at a defined temperature. That means, suppose as we know that the solubility of solute A is 10 mg per ml at 25 degree Celsius temperature. Now, what happens in this solution? The amount of A will be, it has to be added, the amount of A will be more than, the amount of A will be more than this 10 mg, means it will be 12, suppose it will be 12 mg per ml, or it may be 13 mg per ml. Likewise, means the amount of solute A will be more than its saturated concentration. Then we call it as supersaturated solution. Now, in supersaturated solution, what happens? More of the it can dissolve more dissolved solute than it would normally contain in a saturated state at a defined temperature. And the supersaturated solution is mainly used when we are considering the process of crystallization. Then comes solubility expression. So, we can express solubility as quantitative expression, then we can use descriptive term as given according to pharmaceutical compendials and according to US pharmacopoeia and national formulary. Now, first is quantitative expression. It can be expressed as molarity. Now, molarity is the number of moles of the solute which is present in 1 liter of solution is called as molarity. Molality, when means number of moles of solute is present in 1 kg of solvent. Normality, when the number of gram equivalent weight of solute present in 1 liter of solution. Mole fraction, when the number of moles of solute divided by total number of moles of solute plus solvent. Then comes percentage by weight. Percentage by weight means it is the weight in numbers of the solute which is present in 100 grams of the solvent. Means 100, sorry, we can say it 100 grams of solution. Then comes percentage by volume. It is the it is the volume amount, how much volume of solute is present in 100 ml of solution. Percentage weight in volume, it is how much amount of solute in grams or weight is present in 100 ml of solution. Then comes the descriptive term. This descriptive terms are basically used for those drugs whose solubility is unknown, like the solute is termed as very soluble when it requires less than 1 part of the solvent to dissolve 1 part of the solute. The solute is called as freely soluble when it requires 1 to 10 parts of the solvent to dissolve 1 part of solute. Soluble solute when it requires, when the solute requires 10 to 30 parts of the solvent to dissolve 1 part of solute. Sparingly soluble when the solute requires 30 to 100 parts of solvent to dissolve 1 part of solute. Slightly soluble when it requires 100 to 1000 part of solvent to dissolve 1 part of solute. Very slightly soluble when it requires 1000 to 10,000 part of solvent required for dissolving 1 part of solute. Practically insoluble when it requires more than 10,000 amount of part of the solvent to dissolve 1 part of solute. Then comes The third one is according to Pharmacopoeia and National Formulary. Here actually USP has listed the solubility of a number of drugs according to how much amount of solvent in ml is required. For example, boric acid. It requires 1 gram of boric acid requires 18 ml of water to dissolve. 1 gram of boric acid requires 18 ml of ethanol to dissolve. 1 gram of boric acid requires 4 ml of glycerol to dissolve. Then comes the solvent-solute interaction. So, when we have discussing about the solubility of a drug in a liquid, we have to focus on the solvent-solute interactions. So, before entering into this interaction portion, we should have some idea about the forces which is acts in a molecule. Basically, in molecule 2 types of forces are there. One is intramolecular force and one is intermolecular force. So, basically here we are going to focus on intermolecular force of attraction. So, the binding force between the molecules which act are basically cohesive force and the adhesive force. Cohesive force, as we know that it is a force which exists between like molecules. That means, suppose if we are taking solute A, then the force which exists between A and A, between solute is called as cohesive force. The force which exists between the solvent, suppose B is taken as the solvent, then the force which is between B and B is called as the cohesive force. Adhesive force, it is the force which exists between unlike molecules. That is, if A is the solute and B is the solvent, then the force which exists between A and B is called as the adhesive force. And when the molecule interact, then both type of intermolecular forces are there. One is the repulsion force and the other is the attraction force, and both these forces are important. Repulsion force is important because, repulsion forces are important because it prevents the interpenetration of the atomic orbitals, and attraction force is important because it will help to cohere the two molecules together. So, we will now read about or discuss about the different types of attraction forces. Now, the type of attraction forces mainly we discuss is the van der Waals force of attraction, ion dipole, ion induced dipole force of attraction, ion-ion interactions and hydrogen bonds. So, first we will start with van der Waals force of attraction. This is a very weak force of attraction which exists between the molecules. So, to begin with, again van der Waals force of attraction is of 3 types. One is your dipole-dipole interaction, which is also known as Kissam interaction. Then it has dipole-induced dipole interaction, which is called as the Debye interaction. Then you have induced dipole and induced dipole interaction, which is also known as London dispersion force. So, we will start with dipole-dipole interaction. So, when we discuss about this dipole-dipole interaction, first we should understand what is a dipole. What is a dipole? See, basically these van der Waals force and all, they act, these dipoles and all these acts when the atoms are linked together by your covalent bond. So, covalent bonded molecules can be divided into 2 categories. One which has these dipoles and one which does not have the dipoles. So, one which have these dipoles are called as polar molecules, and one which does not have these dipoles, they are called as non-polar molecules. Now, in case of polar molecules, what happens, why this happens, why some are polar molecules, why some are non-polar molecules. Now, polar molecules, why polar molecules occurs? This is due to the structure of the molecule, due to the atoms which are present in the molecule. That is, suppose if a molecule is made up of A and B, suppose A is your molecule which has electron, means if A and B, in between these two atoms, if there exists a electronegative difference, that means if B is more electronegative compared to A, then there exists a electronegative difference between A and B. So, what happens, the more electronegative atom will attract the covalent bond electron or the electron cloud towards itself. As it attracts the electron cloud of the covalent bond toward itself, it will get slightly negative charge, and it occurs only when your this B has sufficient, there is a sufficient electronegativity difference between A and B. If B is your electronegative atom and A is electropositive atom. Okay. So, what happens, B will attract the electron cloud toward itself and it will get slightly negative charge, and A will get slightly positive charge. So, here it leads to the formation of poles, and we will get polar molecules. Okay. Then we will discuss about non-polar molecules. We all understood what is polar molecules. Now, we will discuss on non-polar molecules. In non-polar molecules, what happens? There is no means between two atoms, they do not have sufficient electronegative difference. So, the electron between these the bond electron is equally shared between both the atoms. Suppose if it is your bond between B dash B. So, both are same atoms. So, no electronegative difference between them. So, what will happen? The electron cloud will be uniformly distributed. So, no poles will be formed. So, these are the non-polar molecules. Okay. Now, what happens? The attraction force, the polar molecules, are known as the permanent dipoles, the one which have permanent dipoles. Now, the attraction force which exists between two permanent dipole, the attraction force which exists between two permanent dipole, this attraction force is known as dipole-dipole interaction, and it is also called as Kissam interaction. Okay. Then we will read about dipole induced dipole. These permanent dipoles has the ability, this permanent dipole has the ability to induce dipole in the nonpolar molecules. So, as it induces dipole in these nonpolar molecules, it converts this nonpolar molecule into a dipolar molecule. Okay. And this is known as induced dipole. Now, the interaction which exists, between a permanent dipole and between a induced dipole is called as Debye interaction. Then comes the induced dipole and induced dipole interaction. In the case of induced dipole and induced dipole interaction, it is also known as London dispersion force. It is the force of attraction which exists between two induced dipole. Now, suppose there are two nonpolar molecules are kept together, then they collide with each other. These two nonpolar molecules will collide with each other, and as they collide with each other, there will be a disturbance in the electron cloud and there will be a disbalance in the distribution of electrons. Due to this disturbance in the distribution of electron cloud, they will your polar dipoles will be created. So, this will become this dipole will be created. So, this is a induced dipole is created. Here also you have a induced dipole. So, the attraction force which exists between these two, induced dipole and induced dipole, and this attraction force is known as London dispersion force, and it is very important when we are considering non-polar solvents and non-polar solutes. Then the next, apart from this van der Waals force of attraction, there are other forces of attraction which are ion dipole, ion induced dipole forces. Now, in ion dipole forces, the best example if we take is of an ionic compound sodium chloride. Sodium chloride, they are bound together by electrostatic force of attraction, and what happens when it comes in contact with water, then the cation, that is Na plus ions, that is the cation, it is attracted towards the negative part of that is towards oxygen of water, and the chloride, which is the anion or the negatively charged ion, it is attracted towards the positive hydrogen of water. So, we can see here this sodium ion will get solvated by the water molecules. If this is your oxygen, it is getting slightly negative charge. Here we have hydrogen, it has slightly positive charge. Here we can see likewise. likewise this will be surrounded by your oxygen. The in polar, as we know that water is a polar molecule. So, its partially charged negative charge oxygen is faced towards your sodium cation. And in this way it gets dissolved in water. So, then in the next class we will discuss on ion-ion interaction and hydrogen bond and we will discuss on different polar and non-polar and semi-polar solvents, and all this you can refer Martin, and thank you.